right, so this is the final lesson in our section on conics. And before we jump in with a bit more on central conics, I want to briefly mention, if you notice at the beginning of the notes, there is a bit of a mixed review. So part of your classwork will be a mixed review, which is where we're going to review some of the circle equations, parabola equations, and then graphing relations. All right, I'm not going to go into depth here in the notes because, again, it should be reviewed, so it should come back pretty quickly. So let's look at our lesson today, 9.6, which is titled More on Central Conics. So if you don't realize this yet, central conics are circles, ellipses, and hyperbolas. Okay, and that's because they have centers. So an ellipse has a center, a circle has a center, and hyperbola has a center. And up until now, in the past two lessons, our ellipses and hyperbolas have had a center of 0, 0. Today, we're going to be looking at ellipses and hyperbolas where the center is not 0, 0. Okay, so they're going to be moving. So originally, all of our graphs were centered around the origin, and now our graphs are going to be translating horizontally, vertically, you name it. Okay, so first, let's look at some ellipses. These are ellipses with center HK, so you'll notice that our formula for our ellipses is going to change a little bit. If we have a horizontal major axis, then our formula is going to be x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. So the difference here is that instead of being x squared and y squared, it'll be x minus h quantity squared and y minus k quantity squared, respectively. The a and the b are exactly the same as they were in previous lessons. So the largest denominator is a squared, the smallest is b squared. Okay, and in this case, because it's a horizontal major axis, your a squared should be larger and under the x. For your foci or foci, they are going to be at h minus c comma k and h plus ck. And you're like, well, how do I find c? It's how we were finding it before. So where c squared is equal to a squared minus b squared. So if you remember from the previous lessons, our foci for ellipses centered around 0, 0 were c comma k comma 0, negative c comma 0. And now we're just changing it to h minus c, h plus c, because our center is no longer 0, 0, so the h will vary. And then for ellipses with a vertical major axis, we've got x minus h squared quantity squared over b squared plus y minus k quantity squared over a squared equals 1. Okay, so if it's a vertical major axis, that means, again, the a squared should be underneath the y, right? And then your foci now, instead of adding c and subtracting c from h, you're going to add and subtract c from k. And again, finding c the same way we did before by solving. Okay, so let's look at a couple examples. So first we're going to look at number 4. In number 4, they give us the points of our foci, which are negative 5, 1 and 3, 1, and then they give us the sum of a focal radii, which is 16. And we're going to use the sum of focal radii later to solve for A, but first what we got to do is figure out what our center is. Okay. And the way to find our center is to find the midpoint. And the way we're going to find the midpoint is using the midpoint of the foci. And that's because the midpoint of the foci segment, the segment connecting the foci, has to be our center. So our midpoint is going to be negative 5 plus 3 over 2 and 1 plus 1 over 2. So this is going to be negative 1, comma 1. So this is my center, negative 1, 1. The next thing I need to do is I need to figure out C, right? Because I can figure out A, I can figure out C, but I can't figure out B without having both pieces. So first thing I'm going to do is figure out C. And the way to figure out C is to solve for it with one of the foci. And so I'm going to use 3, 1 because it's positive, okay? And so that tells me, since my C originally has a negative H value, that I'm going to be adding some C to this to get 3. So if I'm looking at 3, 1, then I know that negative 1 plus c, comma 1 has to be equal to 3, 1, right? By ways of my formulas. So I'm going to solve by setting negative 1 plus c equal to 3, and so c has to be equal to 4. So this means that c squared is 16. The next step is to find my a, and the way to do that is what we did in the previous lessons with ellipses, which is we set the focal radii, the sum of the focal radii, which is 16, equal to 2a, because that still holds true here. So a has to be 8, which means that a squared is 64. So I know that a squared is 64, c squared is 16, and now I need to find b squared. And the way to do that is to rewrite that equation, c squared equals a squared minus b squared. So b squared is equal to a squared minus c squared. So this means we've got 64 minus 16, which is equal to 48. And so my answer is going to be x plus 1 squared over 64, right? Because since I added c to the h value of my center, that means that my major axis is horizontal, plus y minus 1 squared over 48 is equal to 1. And this is my equation. Let's look at another one. 6, we have the foci negative 10, 2, and negative 2, 2. And the sum of the focal radii is 14. So first thing we're going to do is find the midpoint to find our center. So that's going to be negative 2 plus a negative 10 plus a negative 2 over 2, and 2 plus 2 over 2. So we end up with a negative 6, 2 as our center. Okay, next I'm going to find my c. So if you look at the points we're given, the change is in the x coordinate. So that tells me I'm looking at h plus c, h minus c. So I'm going to solve using the first point this time. So that means that I'm going to say that negative 10, 2 has to be equal to negative 6 minus c, comma 2. So that means negative 10 has to be equal to negative 6 minus c. Right, and that has to make sense to us here because we went from a negative 6 to a smaller negative number, so we have to be subtracting c from this. So negative c is equal to negative 4, c is equal to 4. This means that c squared is 16. Next, I want to find a by setting the sum of my focal radii equal to 2a. So a is 7. So a squared is 49. This means from the equation we used in the previous problem that b squared is equal to 49 minus 16, which is 33. And so my equation is going to be x plus 6 quantity squared. My horizontal axis is my major axis, so that means the larger denominator goes underneath, plus y minus 2 squared over 33 equals 1. And we're finished. Okay, now let's look at 14. 14, they give us this equation. It says x squared plus 9y squared plus 2x minus 18y plus 1 is equal to 0. And we need to figure out, first off, what is this equation and what graph does it have? And then we need to graph it. Okay, so first thing we're going to do is we're going to organize it. Get all of the x's together and all of the y's together and everything without an x or y on the other side. This is so we can tell, do we have a hyperbola, do we have a parabola, do we have a circle, or do we have an ellipse? Right? So we end up with x squared plus 2x plus 9y squared minus 18y is equal to negative 1. So right off the bat, I know I don't have a parabola, and that's because I have two squared terms. If I only had one, then I'd have a parabola. But since I have two squared terms, I don't have a parabola. So now I need to figure out, do I have a circle, ellipse, hyperbola, that sort of thing. And the first thing I do is, can I get rid of the constants in front of the x's and y's completely? And the answer is no, I cannot, right? So let's say we factor out that 9. And I notice that no matter what I do, I'm always going to end up with a constant in front of one of my squared terms. So I don't have a circle. So now I have either a hyperbola or a parabola. I'm sorry, hyperbola or an ellipses. And the only way I'm going to figure that out is by completely solving, right? Because one is positive, one is negative. So I'm going to complete the square of the x's and the y's. So I add 1 and 9 to the other side. Okay, and so I end up with x plus 1 squared plus 9 times y minus 1 squared is equal to 9. And then in order to get into standard equation, I've got to get it equal to 1, right? So I'm going to divide everything by 9. And I get x plus 1 squared over 9 plus y minus 1 squared over 1 is equal to 1. So this is an ellipse, and that's because of this positive sign right there in the middle, right? And my center, just reading off standard equation, is negative 1, 1. Okay? And my a squared is the larger denominator, so that's 9. My b squared is the other one, so that's 1. And so c squared is equal to 9 minus 1, which is 8. So c is plus or minus 2 root 2, right? So that means my foci is -1 plus 2 root 2, comma 1, and -1 minus 2 root 2, comma 1. And you can leave it like that. I'm not going to ask you to estimate it as exactly as, maybe somebody else would. And so from here, we're going to graph. So first thing we do is we plot our center, which is -1, 1, right there. Okay, and then normally we found x and y intercepts, right? This time we just need to figure out how far this distance. So a squared would be a is equal to 3 and b is equal to 1. So we're just going to count 3 to the right, 3 to the left, 1 to up, 1 down, and that's going to be our ellipse. So 3 to the right, 1, 2, 3, 3 to the left, 1, 2, 3, 1 up from the center and 1 down from the center. So this is my ellipse right here. So when I graph, try to do your best not to point the ends too much. I noticed that on our quizzes we were making it a little too pointy, okay? And there's my ellipse. I just need to label my center. And then the points, 2, 1, -1, 2, -1, 0, -4, 1, like so. Okay, and that's my graph. Normally I'd ask you to label the foci, but since there are radicals in this, I'm not going to require it. Okay. Okay, now that we've done some ellipses, let's look at hyperbolas that with centers other than 0, 0. So for a horizontal major axis on a hyperbola, it's x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. So this means that the a squared is underneath the positive term, which is x here. Foci are at h minus ck and h plus ck, where c squared is equal to a squared plus b squared. So the main differences between the ellipses and the hyperbola is that hyperbola has this negative sign there and a squared is underneath the positive term. And then that the c squared is found with a squared plus b squared rather than minus b squared. For the vertical major axis, we just flip it. So now the y squared term is positive, a squared is underneath it appropriately, minus x minus h quantity squared over b squared equals 1. And the foci are at hk minus c, hk plus c, where c is still found using c squared equals a squared plus b squared. Okay, so that's relatively the same, all right? Really the big difference is just in how you write up the equation in the overall scheme of things. So let's look at an example. Number 8, we have the foci 0, 4, and 0, 10, and the focal radii, the difference of the focal radii is 4, okay? So first thing we're going to do is we are going to figure out our midpoint, because just like with ellipses, hyperbola's center is the midpoint of the segment connecting the foci. So midpoint here is what we're going to look for first. And that's going to be 0 plus 0 over 2 and 4 plus 10 over 2. This is going to be 0, 7. So this is my center. Next, we need to figure out C. Now, because the difference is in the y coordinate of each of these foci, that means that I'm looking at a vertical major axis. So my foci are this formula here that I'm currently highlighting with the pointer. Okay, so I'm going to solve for 10, because that means I'm adding c to it, right? Because we have 7 and we get to 10 somehow. So that means that 0, 7 plus c has to be equal to 0, 10. So 7 plus c has to be equal to 10, c has to be equal to 3. So c squared is 9. Then to find my a, I need to set 2a equal to 4, right? That's the same formula. A is equal to 2, so a squared is 4. This means that 9 is equal to 4 plus b squared, so b squared is 5. So my equation, since it's a vertical major axis, it means the y is going to come first. So we've got y minus 7 quantity squared over vertical major axis, a squared is positive, so we're looking for a, that's 4, minus x minus 0 squared over 5 equals 1. And that's the answer. Let's look at another problem. Number 10. We've got the foci negative 5, 3 and 9, 3, and the difference in the focal radii is 6 this time. So if you notice, the change is going to be in our axis. So that means we have a horizontal major axis for our hyperbola. Okay? And so again, the first thing we're going to do is find our center. So we're going to find our midpoint. So negative 5 plus 9 over 2, 3 plus 3 over 2. This is going to be 2, 3. Okay? And then we're going to find our C by solving, right? So that means if I have a horizontal major axis, I'm adding C and subtracting C from my x coordinate of my center. So that means I'm going to do 2 plus C, 3 has to be equal to 9, 3, right? So 2 plus C has to be equal to 9. C has to be equal to 7. So C squared is 49. Next, I need to find my A by setting 2A equal to 6. So A is equal to 3. So A squared is 9. This means that B squared is equal to 49 minus 9. So B squared is 40. So my equation of my hyperbola here is x minus 2 quantity squared. Horizontal major axis means that A squared is underneath the x term, so that means over 9, minus y minus 3 squared over 40 is equal to 1. And that's my answer. Okay, so 18, this is our last problem, is very similar to 14. Again, they're giving us an equation, and they need us to figure out, is it a parabola, hyperbola, circle, or an ellipse? And then graph. So the first thing we're going to do is get all of our terms together. So we're going to put all the x's together, so we get 16x squared plus 64x. All the y's together, so that's negative 9y squared plus 18y, and everything else on the right. And then we are going to, so looking at this, I can already tell that I don't have a parabola because I have two squared terms. Next thing I want to do is eliminate the possibility of a circle. So I'm going to factor out a 16 from the x's because they have that in common, and a negative 9 from the y's because they have that in common. And looking at that, I can't factor out a 9 or a 16 without creating a issue for the other squared term. So this is not a circle because they don't both have a constant of 1. So now I got to figure out is it an ellipse or a hyperbola. So I'm going to complete the square. And I end up with plus 64 minus 9. So I get 16 times x plus 2 quantity squared minus 9 y minus 1 quantity squared equals negative 144. And then I'm going to divide everything by negative 144. So I get negative x plus 2 quantity squared over 9 plus 9 plus y minus 1 quantity squared over 16 is equal to 1. So since the y term is positive, that means my a squared is 16, my b squared is 9, and my c squared must be the addition of the 2, so that's 25. So I'm going to add and subtract 5 from my center to figure out my foci. My center is negative 2, 1, right? So I have a foci of negative 2, 6, and negative 2, negative 4. And if you're wondering why I added it to the y, that's because since the y term is positive in our equation, that means we have a vertical major axis, which means we're adding c to our y coordinate, not our x. Okay, and now you're wondering, well, how do I graph this hyperbola? Because it was difficult enough graphing all of the asymptotes and the foci and getting the parabola, the curves right when the center was 0, 0. And here's a nice trick, and this works for every single hyperbola, okay? So first thing you gotta do is plot your center. And so our center here is negative 2, 1. And I'm gonna zoom in so we can see this a little better. So we go to the left 2, up 1, okay? Now, since our center is negative 2, 1, The next thing we need to figure out is what's our A and what's our B. Now, if you want a quick reminder, A squared was 16, B squared was 9. And the way to figure out how to graph this, first thing we're going to do is we're going to count 4 up, 4 down. Okay, so for the A, so that's 1, 2, 3, 4, and 1, 2, 3, 4. Okay, and then we're going to count 3 to the right and 3 to the left. 1, 2, 3, 1, 2, 3. If you notice, this creates almost a box-like shape. So we're going to essentially create a box where we include our y coordinates of our graph and what might have been our x coordinates for our graph if it wasn't imaginary. So there's our graph. Now what's nice about the box is that our asymptotes have to go through the corners of the box and through the center. So that's what we're going to do. We're going to go through the center and then through the corners of the box, like so. So if you have a ruler, those are going to be super beneficial and helpful when we're graphing on this section. Like so, okay? And then the last thing I do is graph our parabola. Now, because we have a vertical major axis, that means we're going to be going in the y direction with our parabolas. So they're going to be vertical, our hyperbola. And so to help me direct myself a little better, I'm going to plot my foci, which are -2, 6, and -2, -4. So -2, -4, right there. That's F2, and -2, 6, which is F1. And then to graph my parabola, it starts at that point we plotted to create part of our box and goes towards our asymptotes, like so. And there it is. There's our hyperbola. Okay. So the classwork due the 9th and 10th for each block respectively is page 434, numbers 1 through 17 odd, and then the mixed review on page 431, 1 through 9 odd. And there are notes on them. I just felt like it wasn't very necessary to go over it. Okay, but if you do have questions, don't hesitate to put them on the form. And as a quick reminder, in case you didn't see it at the end of your packet, your test on the last piece of our conics is going to be Monday, February 13th for C block, and Tuesday, February 14th for F block. And I will see you in class.